Hi everybody, well, good afternoon, or at least good afternoon while I'm recording this. We'll move on today from what we spoke about last time, which was equilibria, to talk specifically about the feedback mechanisms that are involved in either maintaining those equilibria or taking you to a different one. The four key terms that we'll cover today are above my head, so please make sure you understand all of these four things at least by the time we get to the end of this video. So I want to cover what is negative feedback, what is positive feedback. I want to talk about what a tipping point is. Very briefly, that's when you move from one equilibrium to a new one through positive feedback, and sometimes it can be very difficult or impossible to get back to your previous equilibrium. And then finally, we'll talk about resilience. Resilience is the ability of a system to overcome this change and stay at the same equilibrium. Some systems are better than others at keeping the same equilibrium. Okay, so as usual, I want to start by just looking at the syllabus. At first glance, that looks like an awful lot of stuff in there specifically about feedback, but some of this we've covered already, and it's really not that much new stuff that we need to talk about today. As usual, I would say once I've talked about this, please pause it for a second and just go through these things point by point, and do the same when we get to the end of the video. Okay, so first of all, just paraphrasing, we need to talk about what negative feedback is and how it acts to stabilize a system at the same equilibrium. Then we need to talk about what positive feedback is and how it acts to destabilize, or in other words, take you to a new equilibrium. Then we need to talk about what resilience is. It says here it's the tendency to avoid tipping points and maintain stability. I'll give you 4 or 5 bullet points of typical characteristics of a system that help them to overcome tipping points and maintain resilience. It says here diversity and size of storage. Well, we'll talk about that. Those are things that help systems to be resilient. And it says here we need to talk about humans can affect resilience. I'll do that briefly, but it's one of those things again we'll come back to as we go through the course when we look at specific case studies. And it says here that there can be delays in feedback loops that can make it difficult to model them. Well, that's a statement of fact. I don't think I'll particularly cover that in this video, but just be aware that it can be difficult to model feedback, both positive and negative, and therefore it does introduce problems of modelling. Down here, applications and skills. Well, we need to discuss resilience, and we need to evaluate the consequences of tipping points. Again, I don't know if I'll cover that in this video. That's something that we keep coming back to throughout the course as we look at very specific case studies. So don't worry too much about that. Okay, so moving on. We've covered this already, but I'll just mention it again. A feedback mechanism is the way that the output of a system affects the input. In a steady state equilibrium, stable steady state equilibrium, feedback keeps you pretty much at the same set point, at the same equilibrium. I'll give you some examples of that in a second. In an unstable equilibrium, feedback is positive and it takes you to a new equilibrium. I'm going to give you some examples that should make it a bit more obvious what that means. And then just down here I've said that feedback can be negative or positive. Negative feedback keeps you at the same equilibrium. Positive feedback takes you to a new equilibrium. Okay, so here's some examples. So we've seen this graph already. This is steady state equilibrium. In steady state equilibrium, if you go high above your set point, negative feedback acts to bring you back towards the set point. If you fall too far below your set point, negative feedback acts to bring you back towards the set point. Now there's always a bit of confusion here. Notice that I've not mentioned positive feedback. If you go too high above the set point, negative feedback brings you back, and if you go too low, it's negative feedback that brings you back to the set point again. Positive feedback is a completely different thing. All right, so a couple of examples. One example is you could look at the human body as a system, and we could look at something called thermoregulation. That's the ability of the body system to keep your body's temperature to a set point of around, in our case, 37 degrees Celsius. So I'll take this guy for example. He's having his temperature taken remotely. In these times of coronavirus, by the way, a quick check of seeing if somebody is well or unwell is to see if the body is struggling to keep your body at a set point of 37 degrees. So this guy, if his temperature goes too high, various things happen to his body or to your body. First of all, vasodilation occurs. That means your blood goes towards the surface of your skin to try to get rid of heat. Your blood goes further towards the surface of the skin. Obviously, you start to sweat. So evaporative cooling takes heat away from the skin. Your hair, your body hair, if you have any, lies down flat on your skin to try and reduce insulation, to help your body cool faster. And that acts to bring your body temperature back down towards, in this case, it would be 37 degrees Celsius. Now this guy might become too cold. If you become too cold, pretty much the opposite happens. Vasoconstriction occurs, which means the blood moves away from the surface of the skin. You stop sweating, and you get goosebumps, and your hair stands up. And that's an attempt of the body to maintain a layer of air around the skin to keep some insulation, to keep you a bit warmer. And that acts to bring your body temperature back towards 37 degrees Celsius. Another example that we'll see in some detail later on, the state of the system could refer to population size. Here's a predator and a prey, rabbit and a fox. So if you take the prey population, the rabbit population, if the rabbit population rises and it gets too high, that provides a lot of food for predators. So with some lag time, you expect the predator population to increase as well. There's a large number of predators, as there will be at this point. It brings the prey population back down again towards its equilibrium conditions. If there's too many predators and they bring the prey population down too low, the prey population falls, less food is available for predators, and therefore the predator population falls as well. So this is an example of one equilibrium affecting another equilibrium. I haven't shown two lines here, but you'd expect this similar thing to happen with a lag time between the prey population and the predator population. One affects the other. But the fact is, negative feedback on the prey and the predator population will make them wobble around the equilibrium population size. Okay, hope that made sense. That's negative feedback. I'll give you some more examples, by the way, when I post this video. Here's positive feedback. Again, if we look at body temperature, there's Jack Nicholson. I'm not sure if he's dead though, or if he's hypothermic. It's a long time since I've seen that film. I think he's actually dead. But assuming he's hypothermic, what's happened is he's reached the point where the negative feedback, keeping his body temperature around 37 degrees Celsius, can't cope anymore because it's become too cold, and hypothermia has set in. He's gone from one set point of body temperature to a different set point of body temperature. So what happens in hypothermia is, first of all, you start to shiver, your breathing would slow down, and then your pulse would slow down. Blood is taken away from your extremities and eventually your brain to try and keep the core organs alive, or the core of your body alive, and eventually you become unconscious. And then if you're not treated in a certain amount of time, obviously you die. You've gone from one set point to a new set point with hypothermia. That's an example of positive feedback. The example we normally use in environmental systems is, I've mentioned it before, is something called the albedo effect. There's quite a few positive feedback mechanisms involved in climate change, which we'll talk about when we get to that section. But a really often used example of positive feedback is the idea that the Earth is at a certain set point temperature globally, or average global temperature. As temperature rises because of because of the amount of carbon dioxide and other pollutants in the atmosphere, we start to lose the white covering at the poles, the ice at the poles. And the ice at the poles acts to reflect more sunlight or more heat from the sun. As we lose the white poles, more and more heat is absorbed from the sun, and we end up with this kind of runaway effect where the Earth gets hotter and hotter. You actually really reach something called a tipping point, where we lose so much of the ice or so much of the albedo at the poles that we move towards this equilibrium very, very quickly, and it can become, as I said before, difficult or impossible in future to get us back to our original equilibrium. Okay, so that's the main part of this video. That's what positive and feedback is with examples. By the way, I've shown this as an unstable equilibrium. Obviously, you get negative feedback happening in this equilibrium and negative feedback happening in the other equilibrium. So it's an unstable equilibrium, but it's also the movement from one steady state equilibrium to a very different steady state equilibrium. It's a bit of an oversimplification to show it as a straight line to another straight line. Okay, and then finally, I've covered positive feedback, negative feedback. I've mentioned tipping points. This is just the idea of resilience, and it's fairly common sense. So, as I mentioned before, resilience is the ability of a system to overcome the push towards moving towards a new equilibrium. So it's the ability of a system not to succumb to positive feedback and go to a new equilibrium. Okay, so very basically, if this is an ecosystem, the more complex the ecosystem, the greater it is able, or the more resilience it has. So therefore, if you've got a large number of food chains or a more complex food web, your system is more resilient. If you lose one species, or if one population of a species falls very low, other connections inside your food web take over, and the system is able to compensate or to be more resilient. All right, more food chains, more diversity or more biodiversity, so more species. So the most biodiverse systems on Earth probably occur in tropical rainforests, specifically the Amazon. You have huge biodiversity, so therefore it links back to the first one. You've got more complex food chains and you have more resilience. I don't want to overcomplicate that. We'll come to the idea of niches later. You might want to take a quick look at that. A niche is just a position within an ecosystem of a particular species. And the more positions you have in your ecosystem, the more resilient the system will be overall. Okay, if you have greater storage, so a greater number of storages or greater storage in general, the system, quite obviously, can last longer under certain conditions without going to a new equilibrium. So we're talking here about storage of energy and matter. The greater the storage, the more resilient the system. And then here I've said, again, it comes back to complexity. The greater the number of negative feedback loops, the more compensation the system has to overcome change, and therefore the less likely it is to go to a new equilibrium. The more the negative feedback, the greater the likelihood of staying around your set point. Right, and then finally, I was in two minds whether to include this, but I did in the end, because we'll cover this when we look specifically at ecology. The few of the keystone species. So a keystone species, hopefully I can explain this very briefly. The keystone of a building, specifically an archway, is the one stone here at the centre that holds the same thing in place. You take away the keystone, the whole system collapses, or the whole archway collapses. So a good example of a keystone species is the sea otter. The sea otter is a very common species that occurs in specific Californian kelp forests. And in the 1800s and the early 1900s, the sea otter was hunted very widely by humans for its fur. And what was found was once the sea otter population fell to a very low limit, it was keeping other species in check. So it's a predator specifically of the sea urchin. Once the sea otter reached very low levels, sea urchins moved into kelp forests. They munch away at the bases of kelp seaweeds, and once they destroy the base of a seaweed, they've destroyed the whole plant, or the whole alga, I should say. And whole forests of kelp were lost, specifically not because humans had a big effect on many species within the ecosystem, but because they had effect on this one keystone species that was keeping everything else in check. I don't want to dwell on that because we'll come back to that when we talk specifically in ecology. But just be aware of the existence of some species that are more important in terms of keeping equilibrium in an ecosystem than others. Okay, that's everything I want to cover today. So just before I go, I will just flip back to the syllabus. Okay, so what is negative feedback and why is it stabilizing? I think we've covered that. Positive feedback in terms of destabilization, I think I covered that. I talked about the resilience of systems and what makes them resilient. I talked in terms of biodiversity and storages. I think we could have done more detail about human effects, but I think I'll set that as separate work, and obviously that's another thing we'll keep coming back to. I did mention keystone species as being particular importance there. And the last three things here, including applications of skills, I think that refers more to specific case studies we'll cover as we go further and further through the course. Okay, so I hope you're leaving this with much better understanding now of what feedback is and how it affects the system, and specifically the difference between positive and negative feedback. Okay, as usual, if there's any issues of anything I've covered, or if you think I've not done a good job with the explanations, please just let me know. As usual, stay safe, please, everybody, and stay home. And I'll speak to you in our lessons this week. Okay, take care.